All right, last day we had learned how to find the determinant. Let's say we had something like, say, A is the numbers 1, 2, 3, and 4. Then the determinant of A would be the first diagonal, which is 1 by 4. Take away the second diagonal, which is 2 by 3. And you'll get 4. Take away 6 equals to minus 2. And that would mean we could also say, therefore, A is a non-singular matrix. Okay, that's just a quick recap because you did it already. Just recapping here. This here is what I call the first diagonal, and that's 1 times 4. And then I would use green to be the second diagonal, which is 2 times 3. Good. So now we reach to the next part of our lesson. We want to find out the adjoint matrix. The adjoint matrix. Okay then. So the adjoint matrix is, suppose I have a matrix called A, right? The adjoint matrix will be called A adjoint, like this. Or I saw on the internet sometimes they would write it as ADJ A. But that's a new thing I'm seeing on the internet. This is the way I know it, A adjoint. So I'll do it like that. So let's just suppose if A was a matrix called 1, 2, 3, and 4, like that, then A adjoint is equal to, you take the first diagonal, which I will color in orange. We swap the first diagonal. So that means that the 4 will come up here and the 1 will come here. And then what we do to the second diagonal is we change its sign. We don't swap it. We just leave it right there. But instead of a positive 2, it's now a negative 2. And it'll be a negative 3. Ta-da! We done. That is A adjoint. You realize here the adjoint matrix is an actual matrix, whereas the answer for a determinant is a number, not a matrix. Okay, let's look at the next example here. Another example. If we had a matrix called B, and B was negative numbers, let's say we had minus 1, we have 2, we have a negative 3, and we have 4. Okay, what would that turn out to be then? Then B adjoint is equal to, let's identify our first diagonal is this here. We have to swap that. So the 4 comes on top and the minus 1 comes down in the corner here. You realize when we swap those numbers, we don't change their sign. We keep the sign as they are. The 4 was positive, it moves up here as a positive 4. The negative 1 was negative, and it comes down here as it's negative 1. So you do not change the sign. You carry the sign with the number as you're switching them. However, look at the next diagonal. We have 2 and we have minus 3. We do not swap them. All we do is change their sign. So this 2 stays there, but it comes minus 2. And that minus 3 will change sign and become positive 3. Okay? So what's the rule to find an adjoint matrix. Okay, let's write this rule, right? What's the recipe to find the adjoint matrix? Step 1. Step 1. Swap the numbers in the first diagonal. Swap the numbers in the first diagonal. I hope you know which one is the first diagonal by now, right? And if you don't know what's the first diagonal, let me color code it for you. The first diagonal is the orange one. Swap the numbers in the first diagonal. And step 2, do not swap. Only change the sign. Do not swap. Only change the sign. Only change the signs. Change the sign of the numbers in the second diagonal. In the second diagonal. Let me color code that for you. The second diagonal is the green one. Okay, I hope your eyes working good to see what I just wrote down. Okay, so you'll see me using this symbol, be adjoint. I wouldn't use it this way, even though I've seen it. At least you'll understand what it means. But this is the kind of method, the symbols I'll use, and that is how you find the adjoint. Now go and practice finding the adjoint of matrices. Make up any kind of matrix with 4 numbers and practice the adjoint matrix. And also do my homework, which I will give you now. Bye bye.